The nuclear waste industry is not a fast-moving industry. In general, when people talk about disposal plans, they talk about what will be done in the next few decades or even the next few generations. In contrast, in the drilling industry, things have moved really, really quickly. And so this has moved way faster than anything in the nuclear space. And so it's understandable that nobody had ever thought about using directional drilling for nuclear waste disposal. I think it also reflects a bigger issue, which is that we need more innovation when it comes to nuclear waste disposal. This shouldn't be the only innovative idea out there of how to dispose of nuclear waste. We should have dozens of companies, dozens of ideas of ways that we can dispose of waste safely. And that's a market that doesn't currently exist.
Welcome to My Nuclear Life. I'm Shelly Lesher. Today we have Liz Muller, co-founder and executive director of Berkeley Earth and CEO of Deep Isolation. Deep Isolation is working on a solution that plagues nuclear power industries around the world: how to safely dispose of high-level nuclear waste or spent nuclear fuel. They are not the first group to tackle the problem, but they are the first private company in this space. Deep Isolation has come up with an interesting and promising solution. We speak to Liz about the problem of nuclear waste and her company's solution. I have another special treat for you. My Nuclear Life researcher, Lexie Weghorn, will join me today and discuss this topic with Liz. She starts out the questioning.
One reason that I often hear why people don't tend to like nuclear energy is that there's a nuclear waste problem. Do you think that there is a nuclear waste problem?
Yeah, so when you're thinking about is there a nuclear waste problem, there's really a couple of different pieces to pull apart. So first of all, nuclear waste is in safe storage right now. So there isn't really an immediate urgent, desperate need for a problem. There's some caveats to that. Some people may disagree, but generally speaking, nuclear waste is considered safe where it is right now. The problem is that it's considered safe where it is right now, but for how long is it going to stay safe? And for nuclear waste, you actually have to think out thousands or even millions of years and make sure that you're protecting not just humans and the environment today, but future generations who could potentially be negatively impacted by the nuclear waste. And that's what hasn't been solved. So there has not been any implemented solution for nuclear waste disposal. So talking about long-term solutions, there are some solutions that are in development. There are some countries that are making progress, but there are other countries that really aren't making a lot of progress. And that's where people are concerned that there is a nuclear waste problem because we have not solved the disposal issue.
You mentioned that the waste is stored where it is. Where is nuclear waste currently being stored?
Yeah, so in most places, it's currently being stored near where it was generated. So at the nuclear reactors, many different locations around the world. In the United States, this is at about 100 different sites around the country. Globally, we're looking at even more sites. Some countries have been able to move it, so they have more consolidated locations where the nuclear waste is temporarily being stored, but many haven't. And so many of them, it's just in above ground storage where it was generated.
And what does it look like? What is included in this nuclear waste?
Yeah, so there's a lot of different types of nuclear waste. Most people typically talk about spent nuclear fuel. So spent nuclear fuel by volume is the waste that we have the most of. High-level waste that we have the most of. So it's in ceramic pellets that are then assembled. So these are about 1 centimeter in diameter, very small ceramic pellets that are assembled into fuel rods that are then put together into fuel assemblies. And these assemblies are then either kept in the pools where they're put to cool when they came out of the reactor, or they have been moved into concrete dry casks where they're being temporarily stored above ground. There are other types of waste too. So there are various different forms of research waste, military waste, etc. There's also lower level waste, which is not considered as dangerous, reactor parts, gloves, etc. So there's lots of different types of waste.
So do you think that not necessarily having a long-term plan for this waste is a big enough issue to justify not using nuclear energy?
That's a tricky question. I think that it's important for everybody to reach their own conclusion on that. But I do typically think that if you want to use a source of energy, or really anything for that matter, anything you want to do with your life, you should think about the trash that's going to be generated and make sure that there is a responsible solution for dealing with that. And unfortunately, that hasn't happened when it comes to nuclear waste. We are left still using a source of power, which I happen to be in favor of. I do think that nuclear power is an important low carbon source of power. But in order to really be responsible, you need to solve the nuclear waste problem.
What is Deep Isolation's plan for nuclear waste disposal?
So deep isolation, our plan is fundamentally, let's put the waste in disposal. So that's, I think, the key thing. And there are a couple of different ways you can do this. The innovation that deep isolation is bringing is using directional drilling. So the international consensus is that the best solution for nuclear waste long term is to put it into deep underground isolation. So deep geologic isolation, on the surface, we don't really know what things are going to look like a million years from now. But when you go down deep in the rock, things don't change over millions of years. So it's a pretty good, stable place to put something that can be dangerous for a long period of time. The reason that this hasn't been done is that it's very expensive. And so mining out a repository, which had been the only way people had thought you could get down to these deep geologic repositories, is very expensive. And so you can't really do very many of them, maybe only one per country. For smaller countries, you may not even be able to afford to do one. And for the countries that can afford it, what this means is you have to pick a location, and that's going to become the nuclear waste dumping ground for that whole country. And now you're starting to get into social equity issues. Who wants to be the dumping ground for a country? And it starts getting really hard to cite these repositories. Deep isolation, because over the past 10, 20 years, there's been such incredible innovation in the drilling world. You can now drill down just as deep or even deeper than you would go with a mined repository without needing humans underground, drill out enough space to put the spent nuclear fuel or the high-level nuclear waste, and it's a fraction of the cost, and it's modular. So you could implement this in a more socially equitable way, potentially, for example, disposing of the waste near where it is now, also minimizing the need for transportation, which is another problematic issue.
The mine isolation that you were discussing, is that what Yucca Mountain was?
Yes. So Yucca Mountain is a mined repository. So big tunnels, 18 feet in diameter, trucks going underground, people going underground, etc.
How long has the U.S. been working on something like Yucca Mountain?
Yeah, so Yucca Mountain was officially decided to be the repository for the United States in 1987. There was some work that had been done working towards Yucca Mountain as well as some other options before that. And the agreement was that it would be operational and begin accepting waste by 1998. Now, that never happened. It wasn't operational. There was some work that was done into getting Yucca Mountain partially built, constructed, licensed, but it hasn't received any nuclear waste. Certainly none has been put into isolation.
Can you think of any reasons why horizontal drilling like you recommend hasn't been tried yet for disposing of nuclear waste?
The nuclear waste industry is not a fast-moving industry. In general, when people talk about disposal plans, they talk about what will be done in the next few decades or even the next few generations. I mean, really, this is not a fast-moving industry. In contrast, in the drilling industry, things have moved really, really quickly. From directional drilling, which I had never even heard of 10 years ago, even though it had been going on for probably a few years before that, to now it's just being done day in and day out across the country. And so this has moved way faster than anything in the nuclear space. And so it's understandable that nobody had ever thought about using directional drilling for nuclear waste disposal. I think it also reflects a bigger issue, which is that we need more innovation when it comes to nuclear waste disposal. This shouldn't be the only innovative idea out there of how to dispose of nuclear waste. We should have dozens of companies, dozens of ideas of ways that we can dispose of waste safely. And that's a market that doesn't currently exist.
Are you aware of any other solutions being considered or that you yourself have looked into?
Yeah, so typically there are three serious solutions out there. There's the mined repository approach, which we discussed earlier. There's also vertical boreholes, which have been studied since the 1980s or so. So those have also been around for a while. I do think that there's a lot of merit to vertical boreholes, and in some cases that might be the right solution for a particular location or a particular type of waste. It doesn't have some of the advantages of directional drilling, so you can't get as much space in a vertical hole without going really deep. And when you go really deep, you start getting hotter temperatures, you start getting higher pressures. So if you really want the large volume of space at a depth that is really appropriate, deep enough, but not too deep, horizontal, or some configuration that gives you a lot of space at that one particular, in a particular rock strata, for example, makes a lot of sense. Horizontal also means that there's no direct path to the surface. So assuming you put the waste just in the horizontal section, not in the vertical section, it provides an additional level of protection.
So when you say it has to be deep enough, how deep is deep enough? What is that kind of Goldilocks zone?
Yeah, it really depends on the sort of rock that you're looking at, but we think it's somewhere in the 1/2 mile to 2 miles deep range.
Yeah, so how has it been going so far for deep isolation? What roadblocks have you encountered? Do you see any potential roadblocks in the future?
Yeah, so we've been around for almost 5 years now. So we started out as a small startup company and we're growing quickly now. It's been hard. This is a really hard market to get into. We're really it. There's no other companies out there doing anything even remotely like what we're doing. And the mentality of governments is that this is a problem that is solved, as I mentioned earlier, over decades or even generations. So getting enough traction to begin to move forward is probably the single biggest challenge that we're facing. Now, when you're talking about nuclear waste disposal, you don't want to move too fast. You do want to make sure that you're safe. You want to make sure that you can meet those environmental and regulatory requirements. But at the same time, you're not doing something in a vacuum either. It's important to keep in mind that this is a comparative. So you're not creating waste that never existed and then putting it into a disposal facility. You're taking waste off of the surface and putting it into a disposal facility. So I do think it's important to keep that in mind. It should really be a comparison. Is this safer than the alternative? Rather than, is this 100% perfect in all situations, which is just an impossible bar to meet. But as a company, I think we are very confident that we can meet the current regulatory standards for environmental safety and for human safety. We've been publishing papers on that, peer-reviewed papers, which are available on the web. We're holding webinars. We're inviting anybody to join. If any of your listeners want to join, they're absolutely free to. We do believe that the more people we have looking at our work, the better it's going to be. We're also incorporating feedback. So when people point out something that we should do differently, we appreciate that. And if it's the right feedback, we actually change what we're doing sometimes. So I think that's important to make sure that the solution is robust. So we're feeling confident on that front. And as I mentioned earlier, the biggest challenge that we're facing is getting governments to actually move forward.
Have you used the horizontal drilling yet? Even if you haven't dumped waste in it, have you ever done it?
Yeah, so we're not expecting to become a drilling company ourselves. We're instead partnering with drilling companies who will do the drilling for us. We did do a demonstration in early 2019, so just over 2 years ago, in which we did put a mock canisters, well, real canister, but it didn't have any nuclear waste in it, into a horizontal drill hole about half a mile underground. And then we left it there, and then we went back and retrieved it a few hours later to show that it is in fact retrievable, which was another issue that some people were concerned about.
Why is retrievability an issue?
It's an interesting question. So in the United States and in many other countries, nuclear waste put into disposal is required to be retrievable for up to a certain amount of time. And that amount of time, it really depends on the specifics of the circumstances, but in the United States, you're looking at potentially up to 50 years. And the reasons for that, I think, are several-fold. First of all, you want to be able to change course if something is going wrong. So if you do detect that for whatever reason something unanticipated is happening, you may want to be able to get it out again. There's also a number of people that really believe that it could be valuable in the future, that nuclear waste can be a fuel for next generation advanced nuclear reactor companies. And so having that option of pulling it out again is worth having. That said, I think it's also important to notice that we've got a lot of waste. And so, even if these advanced reactor companies want to use some of it, there's still a lot more that's going to need to get disposed of. So I think the likelihood of retrieving it is pretty unlikely, but it is a requirement to have that option.
How much waste do we have that falls into that category of potentially usable in the future? Like, how much is there?
So globally, you're looking at about 500,000 tons, depending on what you count. And so that sounds like a lot, but if you compare it to the waste that you get from other industries, it's actually a vastly smaller amount. And that's because nuclear waste is really, really dense. So the volume actually isn't the issue. The issue is that it's potentially dangerous for such a long period of time.
And how long is it dangerous?
It could be dangerous depending on the quantities of exposure for thousands to millions of years.
How does the industry plan on dealing with that problem? The problem of recognizing that we're going to put something in storage that is going to be around longer than potentially us. Like, how are we going to market?
Yeah. So it's a really tricky issue. How do you market is a tricky issue. I think that the consensus for deep geologic isolation is because you certainly don't want it someplace where people are going to be able to get at it, right? You want it someplace where people also aren't going to accidentally stumble into it when they're not paying attention. You want it deep underground. The smaller the footprint, the better. So the less amount of space it takes up, the less likelihood that by drilling a well at some point in the future, you're accidentally going to hit it. Again, deeper is better for the same reason. The deeper it is, the less likely you're going to get into that space for some other reason. But, the issue of marking is a really tricky one. And how do you communicate with future generations?
I've heard that France works with vitrification of their waste. Is that a solution to, quote, our waste problem?
So there's a number of countries that do reprocessing, vitrification, that modifies the form of the waste. It doesn't get rid of the problem entirely. It can, in some cases, reduce the volume or make it more stable so that it can be handled easier. But ultimately, it's still going to need to go into disposal.
Just less of it.
Potentially less of it, or easier to handle it when you put it underground.
So you mentioned marketability and generally public opinion. How has public response been to deep isolation and your drilling demonstration that you mentioned?
Yeah, it's a great question. I think that there are such a diversity of opinions when it comes to nuclear waste. So I want to be careful that I don't say, well, this is how the public has responded. But there are quite a few people that recognize that putting nuclear waste into disposal is a good thing. And many people believe that even if they're not supportive of nuclear power. So even if they don't necessarily want to encourage the nuclear industry to move forward, getting it off of the surface and putting it into disposal is generally agreed to be the right thing to do. Now, there's another segment of people, I think a smaller segment, that is concerned that if you do that, you might actually encourage the future of nuclear power, and they don't want that. So maybe they're not in agreement that you should dispose of nuclear waste until you've stopped the future generation of nuclear power. So that's another small group of people. And then there's people who believe, and I think that within the nuclear industry, you see a lot of this. And the right thing to do is to be responsible. And if you've generated the waste, you should dispose of the waste. And I think that there's a lot of people who believe that. There are also people who object to transportation, particularly in the United States. We've seen this more in the United States than we have in other countries around the world, where if you say you already have waste in your state, and we've actually done surveys that confirm this, but you already have waste in your state, it was generated from a nuclear power plant over however many years it's been generated, would you rather transport it out of your state into a different location, or would you rather put it into disposal near the location where it is now and not have to deal with transportation on public roads, etc.? A lot of people would actually prefer to dispose of it where it is now, even if that means doing it in their state or in their backyard. So we've seen pretty wide margins for that. It was about 82% in all of the states that we surveyed, which included every single state that has nuclear power. Big surprise for us. We were hoping to maybe identify a couple of states that were open to the idea of disposal. And of course, this was a limited survey, so nothing I would consider definitive. But it is surprising to me the objections that people have to transporting nuclear waste.
That's surprising to me too, especially because there's states that don't have nuclear power plants anymore, but they still have the waste.
Yes.
They've decommissioned the plants, but they're still okay with the waste there as long as it's safe.
I'm not sure I would go so far as to say they're all okay with having the waste there. I mean, I think some might be, some might not be. But, you don't necessarily have a lot of options. When you had a nuclear power plant and it's been decommissioned and the nuclear waste is sitting there, what are you going to do? You're going to transport it out of your state, maybe, but then there's some issues. Are you going to be able to find a place to transport it to, first of all? And second of all, the communities that you're going to have to transport it through, are they okay with this? Or you leave it where it is now above the surface, or potentially you put it in disposal by going deep underground near where it is now. And it's a hard choice, and there's not a lot of great options.
Have you had problems attracting investors?
Yeah, that's another really good question. We have not really had problems attracting investors. What we have had trouble doing is attracting institutional investors. So we had thought, we're a startup company, we should go to venture capital, this is a great fit, we're going to grow fast, and that never happened. So I think nuclear is scary for a vast majority of VCs. I think that nuclear waste is even scarier. And I think that there is a reluctance or a fear of the sort of time frames that we're working with. The irony is that we think we can actually move reasonably quickly. I mean, like I said, as sort of quickly as you can while still being safe. But, we're looking at demonstration programs in the next couple of years. We're looking at disposal within the next 5 to 10 years. I mean, I really believe that this is possible while being safe. And there are other parts in the nuclear industry, particularly advanced nuclear, where there's a lot of R&D required still, and so you're not able to move as quickly. With nuclear waste disposal, we're not really inventing anything completely new. We are expanding on technology that exists, but the drilling industry has done most of the inventing. And so it's not as hard a path as for other companies. Where we have been successful is with individual investors who care. All of our investors up until 6 months ago were individual investors who believed in solving the nuclear waste problem, who believed in doing the right thing, and who believed in deep isolation. We did close a Series A in late last year, and that was led by NAC International. So that was really exciting for us because it was the first investment by the nuclear industry. And I think it demonstrates that the nuclear industry is now starting to get behind this solution and realize the importance of nuclear waste disposal.
Sorry, what's a Series A?
Series A is, in sort of venture capital language speak, your first valued round of investment. So you can raise capital earlier on without necessarily giving a value to your company. But when you get a big institutional round with an institution that comes in and says, okay, your company is worth this much, I'm going to invest this much and take this percentage of equity in your company, that's considered a Series A.
Congratulations.
It's a big milestone. Yes, thank you.
Do the regulations in the industry scare off some investors as well?
For sure. I mean, that's been the number one reason that we've heard for investors not investing. The irony is it's not that they don't think we can meet the regulations. You know, everybody who's looked at the regulations agrees that, first of all, we can meet them, and second of all, they don't necessarily even need to be changed. You know, some complication around that in the US, but generally speaking, we can meet the standards required by a significant margin. Meeting regulations is something that we think we can do. We don't see that as a big risk area for our company. I think much higher risk is getting customers, and in this case mostly governments, to actually move forward with the solution and to allow us to show that we can meet the regulations. But that's not necessarily how investors see things, and I think regulation just sounds big and scary and risky. And so especially for investors who are not in the nuclear space, that's been the number one reason that they haven't been comfortable investing.
Are you going to be partnering with national labs?
I think there's a lot we can do with national labs. You know, even though the technology exists, there's so much still to be done in terms of how do you implement it and how do you implement it in specific locations for specific waste streams, including things like advanced reactor waste. So we are hoping to partner with national labs and also international groups to do some of that work.
How did you get involved in nuclear waste disposal?
Yeah, another funny question. So I never considered myself getting into nuclear, period, let alone nuclear waste disposal. I'm an environmentalist. I've been running an environmental nonprofit for the past 10 years, and in many ways that's where my heart is. But when it came to the issue of nuclear waste disposal, and we had a vision, and by we, I actually mean me and my co-founder, who is also the co-founder of my nonprofit, who is also my dad, Richard Muller. So he and I had been working together on this nonprofit that we run, Berkeley Earth. And Berkeley Earth looks at tackling big environmental problems and working with big data, and we mostly do global warming and air pollution. But we were looking at solutions for global warming and what could you do, and specifically interested in where can a small team of people have an oversized impact and really do something that will be meaningful. So not just a small impact by small people, but small people with a big impact. And we'd identified nuclear as potentially being interesting. And we'd identified nuclear waste as a big problem. The unsolved nuclear waste problem is holding back the nuclear industry, and understandably so. At the same time, we were also familiar with directional drilling and natural gas. We'd spent some time looking at natural gas in China, and so we were familiar with the technology. And when we heard about borehole disposal of nuclear waste, it was actually my dad's initial aha moment. He said, of course, what a brilliant place to put it. You drill horizontal holes and you put the nuclear waste in there. We later found out that when they were referring to borehole disposal, they were referring to what had previously been the only type of borehole disposal, which was vertical borehole disposal. And so the idea of going horizontally made sense to us because that's what we were familiar with, but it really hadn't been considered by the industry previously. The next thought was, okay, so we did some due diligence on this and we said, okay, this really does seem like it'll make a lot of sense. Do we do this as a nonprofit? Do we write a paper on this and hope that governments around the world will then pick this up and realize what a great solution it is? And I think we heard a resounding no from that. If you want something to go to die, you write a paper on it and you put it on a shelf somewhere where governments are probably never even going to read it. We're in Berkeley, so we're in the Bay Area. We're near Silicon Valley. And so we have a lot of colleagues who've been involved in startup companies and we're familiar with the startup space. And certainly we received some advice, which I think resonated with us, that if you really want to have an impact, you have a big idea, you get investment, and you go for it in a big and meaningful way. So that's what we decided to do, and that was the birth of Deep Isolation.
What's it like working with your dad?
It's great. I mean, he's wonderful. And I think one of the reasons it works so well is that we are so different from one another. So he's a brilliant physicist, scientist, who just delves into new areas whenever he needs to. So geology, let me figure it out. And he's also an inventor. So, as a business person, which I guess I've become over the past few years, I say, we really need some inventions on how to do blah, 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 blah. And he'll say, okay, let me think about that. A few days later, he'll come back with 3 new inventions of how to do something that nobody ever thought was possible. And that's just so much fun to work with him. Also, we trust each other completely. So that's just lovely. And I know that when it comes to the technology, he's got it covered. And I think he feels the same trust when it comes to me on the business side.
Oh, that's wonderful.
We kind of touched on it earlier, but as of right now, what does the future timeline look like for Deep Isolation?
Yeah, so we're looking at significant growth this year. We're looking at going for demonstration programs in the next couple of years. So by demonstration programs, I mean more sophisticated than the demonstration we did a couple of years ago out in Texas. I mean looking at how would we dispose of some sort of specific waste at a specific location, drilling a hole probably at that location and showing that we can meet all of the regulations and requirements of that specific country for disposing of the waste at that location.
So you had mentioned that you did a demonstration before. Was that a vertical hole or was that a horizontal hole?
It was a horizontal hole, yeah, but it wasn't at a waste site. It was at a drilling site. It was a limited demonstration. So really, we did a small diameter disposal, so we weren't looking at a full spent nuclear fuel rod disposal. We were looking at cesium and strontium or something with a smaller diameter.
When you look at disposing at each individual site, how long would it take to study the geological properties of that site to be able to assess how you're going to kind of dig to dispose of the waste?
Yeah, so interestingly, this has been a big hurdle for many previous disposal programs, is understanding the geology. And even if you understand the geology very well at this particular location, how are you going to know that 100 feet away, the geology is going to be the same? It may not be. So this has been a real impediment. We think that even better than understanding the specific types of rock and how that rock is likely to behave is being able to test for isolation. So you don't necessarily need to understand the rock so that you can get the best model out there. You can actually test the rock. And in the pores of the rock, there's typically some small volume of water. And if you can get at that water, you can see how long it's been isolated in that rock, which gives you a good sense, not necessarily for how long it's going to continue to be isolated, but certainly for how long it has been isolated, which is not a bad proxy for how long it's going to continue to be isolated, if nothing were to change. And so we would want to test that the water in those rock formations has been out of contact from the surface for thousands or even millions of years. And I think that that's probably the single most important thing we can do, more important than understanding and predicting what's going to happen in any particular rock formation.
That's really interesting. So that's a very different way of approaching the problem, not just the horizontal drilling, but also how you assess the sites.
Yes, yes, it is. We'll probably need to do both. I think the redundancy of approaches is important.
I am curious, how do you tell that the water hasn't interacted with the surface in thousands of years?
Yeah, so you can do isotopic measurements. You can measure for various different isotopes that would be there if it had been in contact with the surface. You can also measure certain isotopes that are generated deep underground, and so you can also get a proxy for flow upwards in addition to flow downwards.
Very cool.
Is there anything else you'd like to add or anything else that you'd like our listeners to know?
Yeah, so I guess I'd really encourage any listeners who are interested to join our information sessions, to join our webinars, if they're technically inclined, to read our papers and to send us comments on them and to look for mistakes. This is a really hard problem, and we need all the help that we can get. And we really do value input from intelligent people from around the world. So deepisolation.com is our website. There are some webinars coming up that are open to the public, so your listeners are welcome to join. But they can also even email me directly, liz@deepisolation.com. And yeah, we were very sincere about welcoming input and thoughts on what we're doing.
Thank you for listening to another episode of My Nuclear Life. To find out more about deep isolation or send comments or suggestions to us, please visit our website, mynuclearlife.com. It was a pleasure for Lexie and I to speak to Liz, and we thank her for the time she took out of her busy day. Personally, I would like to thank Lexie Weghorn for all of her help with this podcast. She is graduating soon and off to graduate school in nuclear physics. I'm sure you will join me in wishing her the best of luck on her new and exciting adventure. Please tune in next time when I speak with Tim and Joanna Smolka about nuclear music. Yes, you heard that right. We're going to speak about the intersection of nuclear science and music. Until then, I'm Shelly Lesher, and this has been My Nuclear Life.